In this example, we're calculating acceleration. We're given that the initial velocity of the ball is 2.0 feet per second down. We're also told that the final velocity of the ball is 11.6 feet per second down. And we know from the figure that the time interval between those two velocities is 0.30 seconds. So that's all the data we have. How do we get acceleration from that? Well, we have an equation. Acceleration equals final velocity minus initial velocity over time. We just have to figure out what to plug into the equation. Well, let's start with final velocity. That was given 11.6 feet per second down. So I need to put 11.6 feet per second in for final velocity. Now I'm going to make feet per second a fraction, and I'm going to abbreviate feet as FT and second as SEC, just so I have room to complete it here. All right, the next thing is initial velocity. We were given that as 2.0 feet per second down. So we'll put that in for initial velocity, once again expressing feet per second as a fraction. Finally, we have the time. The time is given as 0.30 seconds, so I can put that in for time in the equation. All right, we have everything we need now. We just have to chug through the math. I have to do the subtraction first. 11.6 feet per second minus 2.0 feet per second is 9.6 feet per second. So acceleration is 9.6 feet per second over 0.30 seconds. Now remember, a fraction just means divided by. So I could rewrite this equation as 9.6 feet per second divided by 0.3 seconds. Now remember what we do here. We take the numbers and group them together. So I got 9.6 divided by 0.30. That's 32. So I have 32, and then I have feet per second divided by seconds. How in the world do I evaluate the expression feet per second divided by seconds? Well, we have to remember something from math. One way we divide things is simply invert them and multiply. So I could rewrite this equation as acceleration equals 32 feet per second times the inverse of seconds. Well, the inverse of seconds is just 1 over seconds. So I have 32 feet per second times 1 over seconds. That's easy to evaluate. Feet times 1 is just feet. Seconds times seconds is just seconds squared. So 32 feet per second times 1 over seconds is 32 feet per second squared. Now we're talking acceleration here, so we have to include a direction. The ball is falling down, so the acceleration is 32 feet per second squared down. The unit feet per second squared is one of the standard units we use for acceleration. Because of the equation for acceleration, the unit must be a distance unit divided by a time unit squared. So feet per second squared is one of the standard units we use.